Hello, everyone. My name is Jack Grogan with Veritas Petroleum Services, better known as VPS. VPS is the global leader in marine fuels testing. We've tested more than 2 million samples in our database. And today I'm here to talk to you about the usual topic, very low sulfur fuel oils, their quality, and what we've seen so far this year in 2020. So I'm going to go ahead and share the presentation now. All right, hopefully everyone can see that. IMO 2020, VLSFOs, the story so far this year. So we'll start with some supply and demand statistics. So from January 1st, there was an immediate switch to VLSFO. In August of 2020, VLSFO accounted for 65% of all samples received at VPS. High sulfur fuel, 21% of samples, gas oil, 12%, and ULSFO 2%. Singapore has been the largest VLSFO bunker port, but there has been wide availability across the globe for VLSFOs. The COVID-19 pandemic hit us all in February or March, so fuel demand across the world was reduced from March through June. Starting in July and August, we did start to see some recovery, but the effects of the pandemic still go on. The anticipated increase in MGO demand never really materialized. High sulfur fuel oil, on the other hand, the demand has increased each month since February. VPS has actually seen a 43% growth in the past 6 months, so this indicates increasing scrubber usage. As far as VLSFO compliance, if we look at sulfur levels, sulfur has varied throughout 2020. Sulfur levels greater than 0.5% varied by month from 1.1% up to 6%. Currently, 3.7% of VLSFO does exceed the 0.5 sulfur mark. And as of August 2020, 0.8% of samples were above 0.53% sulfur, which was double July's level. As far as SOLAS compliance, VPS have issued 37 bunker alerts year to date. 17 of these bunker alerts were related to Flashpoint, 9 of them on MGO, 5 on VLSFO, and 3 on high sulfur fuel oil. Due to the COVID-19 pandemic, road and aviation fuel demand significantly decreased. So there has been increasing speculation that some of the road and aviation fuel has been blended into marine fuels, and this could potentially explain some of the bunker, some of the flash. If we look at viscosity and density, we first look at viscosity on VLSFO, and you could see the global map there showing values in different regions of the world. You see a wide variance, anywhere from 5 centistoke up to 407 centistoke. So the old days of getting 380 CST every week, every month are over. Engineers now have to deal with fluctuating viscosities and densities. 77% of the fuels were below 180 CST, so in general, you're dealing with lower viscosity fuels than you were accustomed to a year ago. Only 4.7% of the fuels were above 280 centistoke. Viscosities have lowered a bit over the year due to lighter materials being blended in. Similarly, on densities, we also see a great variety and a wide range of densities across the globe. Currently, we're seeing a range of 853 up to 1008 kilograms per cubic meter. 60% of these lie in the range of 920 to 950, so quite a bit lower than what chief engineers were accustomed to a year ago of 991, 990. Only 2.8% of the VLSFOs were above 981. Well, there is some good news on the CAT fines, alumina silica. CAT fines have improved significantly during the year 2020. In January, 22% of samples were above 40 ppm. And as of August, only 9.6% were above 40 ppm. So we are seeing a downward trend in CAT fine content, which is good for ship owners. But of course, there's still a wide range. The current minimum that we see across the globe is 2 parts per million, extremely low. Current maximum, 313 parts per million, which is catastrophically high for a marine diesel engine. The global average sits at 14.9 parts per million, which is quite low. The improvement in these CAT fine levels is primarily due to lower levels of residual component being blended into VLSFO. Sorry about that. One of the main concerns with VLSFO is stability. It is the most concerning issue. Regions across the world have averaged anywhere from 0.01% up to 0.03%. The limit is 0.1%, so on average, low sediment fuels. Despite this, many stability issues do arise that do not meet the ISO 8217 upon delivery. And one thing to note well is that VLSFO does not have a long shelf life, so we recommend that you don't store your VLSFO greater than 3 months. Cold flow properties is somewhat of a new issue on black oils. VPS has developed a wax appearance test, which is somewhat similar to Cloud Point for distillates. And we have applied that to VLSFOs across the world. What we found is that 99% of VLSFOs have a pour point less than 30 centigrade, the ISO limit. So that is good. What we did find is that wax appearance temperature is on average 24 degrees centigrade higher than pour point. So quite a wide range from pour point to wax appearance. 78% of these fuels have a wax appearance temperature greater than 30 centigrade. WDT is the wax disappearance temperature. So once wax has formed in your fuel, you'll need to heat it to the wax disappearance temperature in order to reliquefy it and use it suitably in the transfer system. So what we found on wax disappearance is that on average it's 10 degrees centigrade higher than the wax appearance temperature. So if these fuels drop in temperature, you'll need to heat them quite a bit to reliquefy them. 77% of VLSFOs have a wax appearance temperature above 40 degrees centigrade, which is quite elevated. And VLSFO storage temperatures are key to avoiding some operational problems. So just to illustrate a couple of the situations we've seen and some of the advice we're giving to our customers in this area, we find some VLSFOs with high total sediment and at the same time high wax appearance temperatures. So heating these fuels above the watt to prevent cold flow issues can also cause the sediment to rise. When the fuel is eventually burned, the sediment could be off-spec and thick sludge formed. Typically, this fuel forms sludge at the purifiers, and increasing the temperature has generally worsened the situation. The recommendation we're giving here is that we limit VLSFO bunker storage time to 2 months or less. Another situation we see are VLSFOs with low viscosity, and what I mean by that is less than 10 centistoke, and at the same time, high wax appearance temperature above 40 degrees centigrade. So fuel separation temperature is below the Watt temperature, so the vessel cannot heat above the wax appearance temperature. This can cause a problem with sludge formation in the tanks and transfer pipelines, resulting in filters clogging with wax, together with handling issues and transfer issues. So in this case, there can be some controlled use of additives in certain cases, which could improve the situation enough to use the remaining fuel. The last situation I'll mention is VLSFOs where the wax disappearance temperature is above 75 degrees centigrade, which is a very elevated temperature. In this case, we need to be very mindful of the flash point. So we would suggest carrying out an exact flash point test in order to make sure that the fuel is not being heated above that flash point temperature. Now, on the issue of off-spec rate, off-specs quoted here relate to ISO 8217 specification limits. Currently, we're seeing 7% of VLSFOs exceed at least one test parameter spec. So when you compare that to high sulfur fuels from a year ago, high sulfur fuel was typically had an off-spec rate of anywhere from 10 to 13%. So at 7%, VLSFO off-spec rate is already better than high sulfur fuels. Sulfur accounts for almost half the off-specs, so that is the thing to look for. Europe currently has the highest level of off-spec VLSFOs at 17%, mostly due to sulfur. Singapore currently at 4.2%, mainly flashpoint. Another phenomenon that VPS encountered was in the first quarter of this year. We witnessed over 40 vessels that had broken piston rings, damaged cylinder liners, and hard deposits on their pistons. We conducted an investigation, and in May of this year, we published a white paper on our findings. What we found is that all of these vessels were burning on-spec VLSFO. Keyword there is on-spec. All of these vessels were using lubricating oil with a base number of 40. Two-stroke engines seem to be the most susceptible to this condition. Numerous fuel and lubricant suppliers were involved, various engine manufacturers, so was not limited to any particular fuel, lube oil, or engine. And what we found was that the cause was that the reserve base number of the cylinder oil was not being utilized to neutralize acids from fuel combustion due to lower sulfur. The result is that they got hard calcium deposits on the piston crown, causing lining wear, scuffing, and broken piston rings. When the base number is reduced, detergency reduces, and the oil film is lost. When the base number is increased, detergency improves, the oil film is retained, but deposit formation would start. So lastly, I'll touch on bunker quantity survey and how VLSFO has impacted bunker quantity surveys. So in January of 2020, we published a circular that highlighted a quantity shortage of 140 metric tons, quite a significant amount. The contributing factors here were that the VLSFO was not stabilizing in the sounding tubes, leading to inaccurate measurements. Prevailing low ambient temperatures were causing a waxy condition of the fuel and poor flow of the fuel. Chief engineer issued a note of protest to the supplier. So it's therefore very important to engage a professional bunker surveyor in order for the parties concerned to know the following: precautions taken during bunkering to detect these types of losses, independent assessment of the situation and notification of the issues on site, the final quantity difference encountered and the possible reasons. And something that an old boss of mine was a stickler for was documentation. If you don't have documentation of something, then it never really happens. So documentation of the action taken and photos are definitely very helpful, something that VPS surveyors will do during any BQS. Follow-up actions at the next port, assessment of completed investigation, and provision of a conclusion on the quantity difference. And of course, as always, it's important to follow correct sampling procedures to make sure you've obtained a representative sample. So in summary, VLSFO is the most popular bunker fuel of choice. It has wide geographical availability. We have seen a 43% increase in demand for high sulfur fuel oil over the last 6 months, so scrubber usage is on the rise. There was no real increase in the demand for marine gas oil, as many speculated last year. VLSFO sulfur compliance has varied from 1% to 6% off specs. COVID-19 has had its impact and could be a potential explanation for the rise in flashpoint issues. Densities and viscosities on these fuels continue to vary quite a bit, so chief engineers need to read their fuels reports, be aware of the viscosities, densities, storage temperature, transfer temperature. Cold flow issues are common now, and they can impact your vessel operations. VLSFO and lube oil behavior do require close monitoring to avoid cylinder liner damage. And numerous factors during 2020 resulted in the need for an increased focus on fuel management. So if anyone has any questions about the presentation or you're interested in VPS services, please do drop me an email at jack.grogan@v-p-s.com. And thank you very much for your attention.